Now in this video we will find the modulus of a complex number. First we have to keep in mind that modulus give a positive value all the time. So modulus of a complex number is the distance between the origin and the point representing the complex number. So this distance is positive. Distance is always positive. So actually the modulus of a complex number is this distance from O to P. So OP is the modulus of the complex number. Now let's see how it happens. P is a point A, B, and this point is representing a complex number in the Argan plane. This is the Argan plane. It has x-axis and y-axis. This is the real part or the real axis, and this is the imaginary axis. Z is a complex number a plus bi iota, and modulus of z is equal to under root a square plus b square. Now here this we can show on in the Argan plane, and we can point at the complex number by AB in the Argan plane, where A is the real part and B is the imaginary part, and we are showing this on the real line and imaginary line. Here what we see that we form a rectangle with the length A and breadth B. These are the lengths. So our purpose is to find the diagonal, because diagonal, the distance from the origin to the point representing the complex number is actually the modulus. So this we have to find. That is actually the diagonal, or if we take a triangle, then here it is the hypotenuse. So we can use the Pythagoras theorem, and we can find out the hypotenuse by doing the under root of the length square plus the breadth square, or the base square plus the hypotenuse square, and in this way we get the hypotenuse, which is actually the modulus. Because in the previous slide I already told that modulus is nothing but the length from the origin to the point representing the complex number. So H is equal to mod of Z. Mod of Z, or modulus of Z, is equal to under root a square plus b square. We simply do the square of the real part of Z and the imaginary part of Z. This is more mathematical expression of modulus. Now we go through the properties of the modulus. So if the modulus of any complex number is 0, then the complex number itself is 0. The proof is, let z is equal to a plus b iota, where a and b are real numbers. Then modulus of z is equal to under root a square plus b square, and we already have given that modulus of z is equal to 0. Now it means a square under root of a square plus b square is equal to 0, or squaring both the side we get a square plus b square is equal to 0. Since squares can never be negative, because square every time gives positive value, what we have in our hand is that the possibility when a is equal to 0 and b is also equal to 0, both the real numbers are 0, and hence z is equal to 0 plus 0 into iota, or 0. Another property is the modulus of the complex number is actually equal to the modulus of the conjugate of a complex number. This is a property. Let's prove this. If z is a complex number a plus b iota, then modulus of z is under root a square plus b square from the definition of the modulus. Okay, now if to find the conjugate of the complex number, we just change the sign of the imaginary part, that is plus b becomes minus b. So the conjugate of the complex number is a minus bi. So modulus of this conjugate is actually under root of the real part, that is a square, plus the imaginary part, which is minus b square. So a square will be written as a square and minus b square will be written as b square, because square cancels the negative sign. So we get this term under root a square plus under root b square, which is also used here for the modulus of z, and we get the RHS. And by doing this, we simply see that the modulus of z is equal to the modulus of the conjugate of z. Now the third property here is modulus of complex number is equal to modulus of the negative of the complex number. So let's prove this. Let z is equal to a plus b iota be a complex number. Then modulus of z is equal to under root a square plus b square, already defined. So now negative of a complex number is actually changing the sign at a and b. Actually we are multiplying here. Negative of complex number is nothing but multiplying negative or minus 1 to a plus b iota. Minus 1 into a is equal to minus a, and minus 1 into plus b is equal to minus b into iota. So this is actually minus z. So minus z is minus a minus b iota. So modulus of negative of z or negative of a complex number is equal to actually the under root of the real part of the z or the real part of the complex number, which is minus a. So we are going to do the square of the real part, and plus the imaginary part, which is minus b, the square of the imaginary part. So finally we cancel the negative because square is involved here. So square cancels the negative in both the real part and the imaginary part, and we get a square plus b square. Modulus of minus z is giving the same value that is given by modulus of z. So these are the three properties. If you like the video, please subscribe to our channel and please like this video. Thanks much.